Hello students, welcome. Previously, lesson 35, we were dealing with the second aim of back titration, which was determining the mass of the analyte. So today, in lesson 36, we are going to do aim number 3 of back titration, which is determining the percentage purity of the analyte. Kindly stay with us till the end of the video. Thanks. Example 1. Example 1. We have 1.0 gram of a sample of limestone was allowed to react with 100 centimeter cube of 0.2 molar dilute hydrochloric acid. The excess acid required 24.8 centimeter cube of 0.1 molar sodium hydroxide, and we are told to calculate the percentage of calcium carbonate. In bracket, we are given the relative atomic mass of calcium, which is 40, the relative atomic mass of carbon, which is 12, and the relative atomic mass of oxygen, which is 16. So to start answering the question, we have to get first of all the number of moles of the sodium hydroxide. We have its molarity and also we have the volume. So what was the formula for getting number of moles? So we're going to start moles of sodium hydroxide. Moles is given by molarity times volume used. So the molarity is 0.1 times volume used, which is 24.8, then divided by 1000. So if we put all those, we are going to get 0.00248 moles of sodium hydroxide. Moles of sodium hydroxide. That's the first step. The next step, we have to write the reaction between sodium hydroxide and also hydrochloric acid. So we are going to write sodium hydroxide, which is a solution, reacting with hydrochloric acid, which is also a solution. We are going to get sodium chloride, which is a solution, plus water, which is liquid. So using mole ratio, we are supposed to get the number of moles of hydrochloric acid. So the mole ratio between sodium hydroxide ratio hydrochloric acid is 1:1 because this reaction is self-balanced. So we know the number of moles of sodium hydroxide, it is 0.00248 moles. So we can ask ourselves, what about the number of moles of hydrochloric acid? We can just cross multiply. So we are going to have 0.00248 multiplied by 1, then divided by 1. We are going to get 0.00248 moles of hydrochloric acid. So this number of moles is the number of moles of hydrochloric acid that has reacted with the base, or that has reacted, or in other words, this is the number of moles of the excess hydrochloric acid. So thereafter, the next step, we are supposed to get the original moles of hydrochloric acid, original moles. So how are we going to get original moles? Original moles of hydrochloric acid. We can get the original moles of hydrochloric acid by having the molarity of dilute hydrochloric acid, which is 0.2, multiplied by volume used, which is 100, and divided by 1000. So here, we are going to get 0.02 moles, 0.02 moles of hydrochloric acid. So this is the original moles of the dilute hydrochloric acid. So thereafter, so next we have to get the number of moles of hydrochloric acid that reacted with the carbonate. So we are going to say moles of hydrochloric acid that reacted with the carbonate, and the carbonate that we are talking about is calcium carbonate. How are we going to get that? By having the original moles, then we are going to subtract by the excess moles. So this one we can get it, or we can obtain by having original moles minus excess moles, the excess moles of hydrochloric acid. So by inserting this, we are going to have 0.02 minus 0.00248 moles which is the excess moles of hydrochloric acid. By putting those in the calculator, we are going to get 0.01752 moles, 52 moles of hydrochloric acid. So this is the number of moles of hydrochloric acid that reacted with the calcium carbonate. So the next step, we have to get now the reaction between calcium carbonate and dilute hydrochloric acid so that we get the number of moles of the calcium carbonate that has reacted with the hydrochloric acid. So we are going to have calcium carbonate, which is solid, reacting with hydrochloric acid. We are going to put that to balance the equation. Here we are going to get calcium chloride, which is solution, plus water, which is liquid, plus carbon dioxide, which is a gas. So next, let's get the mole ratio between calcium carbonate ratio hydrochloric acid. So the mole ratio is 1:2. So we have the number of moles of the hydrochloric acid that has reacted with the calcium carbonate to be 0.01752. So let's get the number of moles of the calcium carbonate that has reacted with hydrochloric acid. We cross multiply. So we are going to have the 1 times 0.01752 divided by 2. So here we are going to get 0.00876 moles of calcium carbonate. Moles of calcium carbonate. So thereafter, next step, we have to get the mass of calcium carbonate. And the formula for calculating mass is moles times RFM. So we have to get RFM of calcium carbonate. So we are going to have the RM of calcium to be 40, plus the RM of carbon to be 12, plus the RM of oxygen to be 16 times 3. All this we are going to get 100. So mass of calcium carbonate will be equal to moles, which is 0.00876 times 100. So here we are going to get 0.876 gram. That will be the mass of calcium carbonate. Okay, thereafter, we are supposed to get the percentage purity of calcium carbonate. So we are going to say percentage purity of calcium carbonate. We can use the formula as the pure mass of calcium carbonate divided by the mass of the limestone, then multiplied by 100. So when we put this one here, if we put it, we are going to say 0.876 divided by 1.0 times 100%. So this one, we are going to get 87.6% as the percentage purity of the calcium carbonate in the limestone. That will be the end of that question number 1. So example 2, we are told 1.0 gram of impure magnesium metal is reacted with 25 centimeter cube of 1 molar sulfuric 6 acid. The resultant solution is then diluted to 100 centimeter cube, full stop. Then we are told 25 centimeter cube of this solution is neutralized by 10 centimeter cube of 0.25 molar sodium hydroxide solution. So part A of the question, we are told calculate the number of moles of chromium 1 in 25 centimeter cube of 1 molar sulfuric 6 acid. So how are we going to get moles or number of moles? So we're going to say moles of sulfuric 6 acid. It is given by molarity, which is 1, multiplied by volume, which is 25, divided by 1000. So here we are going to get 0.025 moles of sulfuric 6 acid. That will be for part A, Romeo 1. Then part A, Romeo 2, we are told in 10 centimeter cube of 0.25 molar sodium hydroxide solution. So moles of sodium hydroxide solution. The formula is the same. Molarity, which is 0.25, multiplied by volume, which is 10, divided by 1000. Here we are going to get 0.0025 moles. 25 moles of sodium hydroxide. So next, part A, Romeo 3, we are told of sulfuric acid in 100 centimeter cube of the diluted solution. So here in part A, we are having the number of moles of the original moles of sulfuric acid, part A, Romeo 1. Part A, Romeo 2, we are having the number of moles of the sodium hydroxide that has reacted with the excess sulfuric acid. So here, of sulfuric acid in 100 centimeter cube of the diluted solution, it is linked here. We are told 25 centimeter cube. If we go back, 25, or we are told the resulting solution is then diluted to 100 centimeter cube. So out of this 100, 25 centimeter cube of this solution was neutralized or was reacted with sodium hydroxide, in which it is number of moles we have gotten as 0.0025 moles. So to get now the moles of the sulfuric acid in 100 centimeter cube of the diluted solution, we have to write the reaction between sodium hydroxide and dilute sulfuric acid. So we are going to write sodium hydroxide solution reacting with sulfuric acid solution. Here we are going to get sodium sulfate solution plus water. This is a neutralization reaction. To balance the equation, we have to put 2 there and we have to put 2 there. So let us get the mole ratio between sodium hydroxide ratio sulfuric acid. So it is 2:1. There's 2 here, there's 1 hidden there. So we know the number of moles of the sodium hydroxide. It is 0.0025. So we say, what about the one for sulfuric acid? So we're going to say 0.0025 multiplied by 1 divided by 2. Here we are going to get 0.00125 moles of sulfuric acid. So this is the number of moles of the sulfuric acid in 25 centimeter cube of solution. That means 25 centimeter cube of sulfuric acid had this number of moles. So what about 100 centimeter cube of sulfuric acid? There we are going to relate, and we are going to say if 25 centimeter cube of sulfuric acid can give us this number of moles, which is 0.00125 moles of sulfuric acid. What about 100 centimeter cube of sulfuric acid? What number of moles is it going to give us? We cross multiply. So we're going to have 100 times 0.00125 and divided by 25. So here we are going to get 0.005 moles of sulfuric acid. So remember, learners, this is the number of moles of the excess sulfuric acid. Okay, next we are going to go to part B. We are told calculate the mass of magnesium that reacted with the acid, and we are given the RM of magnesium. So the first step, we are supposed to get moles of sulfuric acid, moles of sulfuric acid reacted or that reacted with magnesium, that reacted with magnesium. How are we going to get that? By having original moles of sulfuric acid, then subtracted by the excess moles of sulfuric acid. Okay, so what is the original moles of sulfuric acid? We have done that one in Romeo A part, Romeo 1, A, Romeo 1. We have gotten 0.025 moles. So we are going to say 0.025 moles minus the excess moles of the sulfuric acid, which we have gotten 0.005 here. Okay, when we put this one in the calculator, we are going to get 0.02 moles of sulfuric acid. So this is the number of moles of sulfuric acid that has reacted with the magnesium. So the next step, we have to get the number of moles of the magnesium that reacted with the sulfuric acid, and we can get that one by writing the reaction between magnesium and sulfuric acid, and thereafter using the mole ratio, we can get the number of moles of magnesium that reacted with the sulfuric acid. So we can write magnesium, Mg, solid, reacting with sulfuric acid, solution. Here we are going to get magnesium sulfate solution plus hydrogen gas. So the mole ratio between magnesium ratio sulfuric acid is 1:1 because this reaction is self-balanced. So we have the number of moles of sulfuric acid to be 0.02 moles. So we can say, what about the number of moles of magnesium? So we cross multiply, we have 1 times 0.02 divided by 1. So this one will be 0.02 moles of magnesium. So next, if I want to get the mass of magnesium, because I'm told calculate the mass of magnesium. Mass is given by moles times molar mass. Or RM in our case, because we are dealing with magnesium, which is a metal. This will be equal to, the number of moles is 0.02 multiplied by 24. So there, we are going to get 0.48 gram as the mass of magnesium. So, next question, but see, we are told calculate the percentage purity of magnesium metal by mass. So, we are going to say percentage purity of magnesium will be equal to the pure mass of magnesium divided by the mass of impure mass of magnesium, then we multiply by 100. So this will be equal to, the pure mass of magnesium is 0.48 divided by the mass of the impure magnesium is 1.0. It is the start of the question. We are told 1.0 gram of impure magnesium. So 1.0 divided by 1.0, then multiplied by 100. So here we are going to get 48%. That will be the percentage purity of magnesium by mass. So that will be the end of our lesson. Thank you.